Hey class, today we're going to talk about chemical reactions. So to start off with, we use chemical equations that are short, easy ways to write about what happened during a chemical reaction. For example, if you have a compound plus a compound turning into a different compound, that's what those chemical equations are going to look like. For example, a reaction of sulfuric acid and sugar, you have C12H22O11 plus H2SO4 turns into 12 molecules of carbon and 11 molecules of water. So the acid is dehydrating the sugar, which forms a pillar of carbon and steam. So the carbon is where you see this black stuff, and then that lets off the steam. Another example would be two hydrogen atoms combining with one oxygen atom to form a water molecule. So we have our 2H2O, we have O2, and that is turning into 2H2O. So it's just a quick way of writing what happened. Chemical equations are going to summarize those changes in that reaction. They're going to tell you what you start with and what you get at the end. Those equations are going to tell a story kind of about what happened in the reaction. What did you start with? What did you end up with? So the substances that we start with are called the reactants. This is what gets the reaction going. This is like your beginning of the story. So this is your once upon a time. The substances that you get at the end are the products. So this is at the end of the story, like your happily ever after. So for example, if we have iron plus sulfur, we have Fe plus S turns into FeS. So you have your reactant and your reactant that's turning into the product. That's what this arrow is showing you. It's what's turning into. So Fe and S are your reactants on the left side of the equation, and FeS is your product that's on the right-hand side of the equation. So you can see here, this is what iron looks like before the reaction. This is sulfur. Combine them, this is what you get. Now, another part of the chemical formula is a larger number that comes before that chemical formula. So, for example, we have 4O2. This 4 right here is called a coefficient. That's going to tell you how many molecules of that compound you have. And this number applies to the entire compound. So, for example, this is O2. We have two oxygen bonded together, and we have 4 different molecules of that substance. So that's what that number tells you. The law of conservation of matter states that during a chemical reaction, matter is not created or destroyed. Whatever you start with as reactants has to be equal to what you end up with as products. So nothing is being added or taken away. It's just rearranging to form new things. For example, if you measured the ash left from a wood fire, it wouldn't have the same mass as the wood that had been burned, but if you had some of it, it would have escaped as gas. And if you trapped them and added it all together, it would still add up to what you started with. So the elements had just rearranged into new things. Another example, if you have N2, you can see we have these two that are bonded together, and then 3 molecules of H2, 1, 2, 3. And then they are turning into 2NH3. So you can see if you count, you still have 2 parts nitrogen as a reactant and 2 parts nitrogen as a product, and you still have 6 parts hydrogen as a reactant and 6 parts hydrogen as a product, but they've rearranged themselves into a different format to create that compound. So if you counted them, they're going to be the same even though you started creating something new. If we look at this equation, on the left-hand side, what are our reactants? That would be C for carbon and H2O. What are your products? CO and H2. So what we use to kind of prove this law of conservation of matter is what we call a brace map table. So we see what we have as reactants, what we have as products, and then we figure out if we have the same amount on each side. So here's our first example. We have C plus H2O. These are our reactants. Okay, we have our arrow. That means they're turning into CO plus H2. So these are your products on this side of the equation. So our first step for every brace map is to find the arrow and draw a line to divide your reactants and your products. Okay, and then this part is just like the other brace maps that we've completed. So we have 1 part C, we have H2, so that subscript tells us we have 2 parts hydrogen, and then we also have an O. So your total on this side is 4 elements. And then if we go to this side, we have a C, we have an O, and then we have H2 with that subscript, so we know that we have 2 parts H. The reactants and the products both total up to 4, so that is how we prove the law of conservation of matter. Notice you have the same number on each side, so there's 1 part carbon, 1 part oxygen, and 2 parts hydrogen. So there's the same amount, not only the same number, but the same amount of each of those elements. So if you think about it like a bank, if you put $50 in the bank, you expect to get $50 back. It's the same with elements in reaction. Whatever you start with is what you're going to end up with. So here's another example. We have 2K plus Br2 turns into 2KBr. Okay, so this is where these coefficients come in. This is new. So this 2 applies to this K. So there's 2 Ks, just as if it would have had a subscript. Okay, and then we have Br2, so we know there are 2 parts. Our total is 4. On this hand side, this coefficient applies to every element in that compound. So since the K and the Br are together like this, there's 2 parts K, K, and there are 2 parts Br. It applies to this element over here too. So again, we have 4 and 4. Both sides add up to each other, okay? So that coefficient is going to be multiplied by the subscript. So in this example, obviously both these subscripts are 1, so it ended up just being 2 parts. Let's look at another example. If we have CH4 plus 2O2 turning into CO2 plus 2H2O, our first step is going to be to find our arrow, and we're going to draw a line to divide it. We have CH4, so we have 1 part carbon, we have 4 parts hydrogen, and then 2O2. So we not only have a coefficient, but we also have a subscript. So we're going to multiply those two numbers. So 2 times 2, we have 4 parts oxygen. Okay, and then our total is going to add up to 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm going to put my total here, and I'm going to add that up. Then we're going to go over to the product side. So we have CO2, we have 1 part carbon, we have 2 parts oxygen, and then we have 2H2, so we're going to take these two, the coefficient, the subscript, we're going to multiply them. We have 4 parts hydrogen on this side. And then this 2 member also applies to the oxygen, so 2 times 1, the subscript that's not there. We also have 2 parts oxygen, so we're going to go back up to where that other oxygen is, and we're going to add it in there. So again, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 on this side. Our numbers add up. We have successfully created a brace map and proven the law of conservation of matter. And that's how you complete your brace map tables.